When performing dwelling load calculations using the general method, including the load of a refrigerator and a separate freezer is necessary. These are considered fixed appliances and contribute to the overall load of the dwelling. However, a microwave hood combination is typically not included in the general method. This is because it's usually not considered a fixed appliance and its load is often covered by the allowance provided for small appliances. Regarding the derating of water heaters, if you have 4 or more fixed appliances and at least 2 of them are 40-gallon water heaters, you can indeed derate each water heater by 25%. The rationale behind this derating is that water heaters are not typically used simultaneously, allowing for a reduction in the calculated load. To accurately calculate the load for appliances such as refrigerators, freezers, and water heaters, always refer to the manufacturer's specifications for their power consumption in watts. For a microwave hood combination, if you choose to account for it separately, a common practice is to use an allowance of 500 watts. Here's an example to illustrate the calculation. Firstly, consider a scenario where you have a refrigerator rated at 1000 watts, a freezer rated at 500 watts, and 2 40-gallon water heaters each rated at 2000 watts. Without derating, the total load would be calculated as follows: 1000 watts plus 500 watts plus 2000 watts plus 2000 watts, which equals 5500 watts. Secondly, if you apply the 25% derating to each of the 2000 watt water heaters, each water heater's load becomes 1500 watts after derating. The total load with the derating applied would then be calculated as 1000 watts plus 500 watts plus 1500 watts plus 1500 watts, totaling 4500 watts. It's important to consult the most current edition of the National Electrical Code or NEC for the specific requirements and allowances related to dwelling unit load calculations. The NEC provides tables and guidelines that must be followed to ensure electrical safety and compliance with regulations. In summary, when calculating dwelling unit loads, firstly, include the refrigerator and freezer as they are considered fixed appliances. Secondly, typically do not include a microwave hood combination, as its load is usually covered under the small appliance circuits allowance. Thirdly, if there are at least 4 fixed appliances and 2 are water heaters, each water heater can be derated by 25%. Fourthly, refer to the manufacturer's specifications for the accurate wattage of appliances, and use 500 watts as a general allowance for a microwave hood if needed. Fifthly, always adhere to the National Electrical Code, or NEC, guidelines for safe and compliant electrical installations. By following these guidelines, you can accurately calculate the electrical load of a dwelling, ensuring electrical safety and code compliance. For calculating the general lighting load for a dwelling, the NEC typically requires a minimum of 3 volt amps per square foot. This value ensures sufficient capacity for general illumination throughout the house. To determine the total general lighting load, multiply the square footage of the dwelling by 3 volt amps. For example, if a dwelling is 1500 square feet, the general lighting load would be 1500 square feet multiplied by 3 volt amps per square foot, which equals 4500 volt amps. Small appliance branch circuits are essential in dwelling units to supply power to various portable appliances used in the kitchen, dining room, and similar areas. The NEC requires a minimum of 220 amp small appliance branch circuits for the kitchen and dining areas. Each small appliance branch circuit is typically rated at 1500 volt amps. Therefore, the total allowance for small appliance branch circuits is 2 circuits multiplied by 1500 volt amps per circuit, which equals 3000 volt amps. The NEC also requires at least one 20 amp laundry circuit for dwelling units to supply power to laundry equipment. This circuit is typically rated at 1500 volt amps. Therefore, a dedicated 20 amp laundry circuit is required, contributing 1500 volt amps to the overall load calculation. For electric ranges and cooking appliances, the NEC provides specific demand factors that allow for a reduction in the calculated load. These demand factors are based on the assumption that not all cooking elements will be used simultaneously at their maximum rating. The demand factors for electric ranges are outlined in NEC Table 220.55. To determine the demand load for an electric range, refer to NEC Table 220.55 and select the appropriate demand factor based on the rating of the range. For example, a range rated at 12 kilowatts or less can have a demand factor applied, resulting in a lower calculated load. For permanently connected appliances, such as water heaters, dishwashers, and disposals, the load is calculated based on the nameplate rating of the appliance. The nameplate rating indicates the maximum power consumption of the appliance in watts or volt amps. When calculating the load for these appliances, use the nameplate rating as the basis for the calculation. For motor loads, such as those found in air conditioners, heat pumps, and well pumps, the load calculation is based on the motor's horsepower and voltage rating. The NEC provides tables that list the full load current for motors based on their horsepower and voltage. To determine the load for a motor, refer to the appropriate NEC table and select the full load current corresponding to the motor's horsepower and voltage. For air conditioning and heat pump equipment, the NEC requires specific calculations to ensure adequate capacity for the equipment. These calculations take into account the compressor motor's lot-rotor current and the ratings of any supplemental heating elements. To calculate the load for air conditioning and heat pump equipment, follow the procedures outlined in NEC Article 440. For electric vehicle charging equipment, the NEC requires specific calculations to ensure adequate capacity for the charging load. These calculations take into account the continuous nature of the charging load and the voltage and amperage ratings of the charging equipment. To calculate the load for electric vehicle charging equipment, follow the procedures outlined in NEC Article 625. After calculating all of the individual loads, the next step is to apply any applicable demand factors to the total load. Demand factors are reduction percentages that can be applied to certain loads based on the likelihood that not all loads will be operating simultaneously at their maximum rating. The NEC provides various demand factors for different types of loads, such as lighting, receptacles, and appliances. To apply demand factors, refer to the appropriate NEC table or section and select the demand factor that corresponds to the type of load being calculated. Multiply the load by the demand factor to determine the reduced load. After applying all applicable demand factors, the final step is to calculate the total calculated load for the dwelling unit. This is done by summing up all of the individual loads, including the general lighting load, small appliance branch circuits, laundry circuit, electric range, permanently connected appliances, motor loads, air conditioning and heat pump equipment, and electric vehicle charging equipment, after applying any applicable demand factors. The total calculated load represents the minimum capacity required for the service and feeder conductors supplying the dwelling unit. It is important to ensure that the service and feeder conductors are sized appropriately to handle the total calculated load in accordance with the NEC requirement. In addition to the general method of dwelling unit load calculations, the NEC also provides an optional simplified method for certain dwelling units. The simplified method is typically used for smaller dwelling units with a limited number of appliances and circuits. The simplified method allows for a more straightforward calculation of the total load, without the need to calculate individual loads for each appliance and circuit. To use the simplified method, the dwelling unit must meet certain criteria outlined in the NEC. If the dwelling unit meets these criteria, the total load can be determined by multiplying the square footage of the dwelling by a specified volt-amp per square foot value. The simplified method can be a convenient alternative to the general method for smaller dwelling units, but it is important to ensure that the dwelling unit meets the NEC requirements for using the simplified method. Understanding and applying these principles and adhering to the NEC guidelines are critical for ensuring the safety and efficiency of electrical installations in dwelling units. This ensures that electrical systems can handle the anticipated loads safely and reliably, while also complying with regulatory requirements. Firstly, always consult the latest edition of the NEC for the most up-to-date requirements and guidelines. Electrical codes and standards can change over time, so it is important to stay informed about the latest revisions. Secondly, consider the specific needs and characteristics of the dwelling unit when performing load calculations. Factors such as the size of the dwelling, the number of occupants, and the types of appliances and equipment used can all affect the electrical load. Thirdly, seek guidance from a qualified electrical professional if you have any questions or concerns about dwelling unit load calculations. A licensed electrician or electrical engineer can provide expert advice and assistance to ensure that the load calculations are performed accurately and in compliance with the NEC. In addition to the specific examples and calculations provided, it is important to have a general understanding of the underlying principles of electrical load calculations. Electrical load calculations are based on the fundamental concepts of Ohm's law and power equations. Ohm's law states that the voltage across a conductor is directly proportional to the current flowing through it and inversely proportional to the resistance of the conductor. The power equation states that the power consumed by a load is equal to the voltage across the load multiplied by the current flowing through it. These principles are used to determine the amount of current that will flow through a circuit and the amount of power that will be consumed by a load. By understanding these principles, you can gain a deeper understanding of how electrical load calculations are performed and why they are important. When performing dwelling unit load calculations, it is also important to consider the impact of energy-efficient appliances and equipment. Energy-efficient appliances and equipment consume less power than their standard counterparts, which can reduce the overall electrical load of the dwelling unit. The NEC allows for certain adjustments to be made to the load calculations when energy-efficient appliances and equipment are used. These adjustments can help to reduce the size of the service and feeder conductors required for the dwelling unit, which can save money on materials and installation costs. To take advantage of these adjustments, it is important to carefully document the energy efficiency ratings of the appliances and equipment being used in the dwelling unit. In addition to the technical aspects of dwelling unit load calculations, it is also important to consider the safety implications. Electrical systems that are not properly designed and installed can pose a serious safety hazard to occupants. Overloaded circuits can overheat and cause fires, and improperly grounded systems can expose occupants to the risk of electric shock. It is essential to follow all applicable codes and standards when designing and installing electrical systems in dwelling units. This will help to ensure that the electrical system is safe and reliable and that it will not pose a hazard to occupants. One important aspect of electrical safety is proper grounding. Grounding is the process of connecting the electrical system to the earth, which provides a path for fault current to flow back to the source. This helps to protect occupants from electric shock in the event of a fault. The NEC requires all electrical systems and dwelling units to be properly grounded. The grounding system must be designed and installed in accordance with the NEC requirements. Another important aspect of electrical safety is proper overcurrent protection. Overcurrent protection devices, such as circuit breakers and fuses, are designed to protect electrical circuits from overloads and short circuits. These devices will automatically trip or blow when the current in a circuit exceeds a certain level. This helps to prevent overheating and fires. The NEC requires all electrical circuits and dwelling units to be protected by overcurrent protection devices. The overcurrent protection devices must be sized appropriately for the circuits they are protecting. In addition to grounding and overcurrent protection, it is also important to use proper wiring methods when installing electrical systems in dwelling units. The NEC specifies the types of wiring methods that are permitted for use in different applications. It is important to use the correct wiring method for the application to ensure that the wiring is properly protected from damage. When working with electricity, it is always important to take precautions to protect yourself from electric shock. Always turn off the power to a circuit before working on it. Use insulated tools and wear appropriate personal protective equipment, such as rubber gloves and safety glasses. Never work on electrical systems when you are wet or standing in water. If you are not comfortable working with electricity, it is best to hire a qualified electrical professional to do the work for you. In summary, dwelling unit load calculations are an essential part of electrical design and installation. By understanding the principles and following the guidelines outlined in the NEC, you can ensure that electrical systems and dwelling units are safe, reliable, and compliant with regulatory requirements. Always consult the latest edition of the NEC and seek guidance from a qualified electrical professional when performing dwelling unit load calculations. Remember to consider the impact of energy-efficient appliances and equipment and to prioritize electrical safety at all times.